So where then does concentration fit into our overall scheme of chemical reactions in stoichiometry? We've done a little bit with titrations, but what if we're doing just a normal chemical reaction like we did in chapter 3, but in aqueous solution? How does this all fit? Well, concentration is related to stoichiometry, and stoichiometry and the balanced chemical equation is related to mass all through moles. So we can see the relationship here in all of this. If shown in white here in the middle is the balanced chemical equation, where I can relate the moles of substance A to moles of substance B. And then I know that I can relate between moles and grams using the molar mass. That I can do, and we've already done that in chapter 3. But if I'm dealing with concentration, well, the way that I relate to this is concentration relates to moles. If I know the volume and the concentration, I can get to moles. Moles can be related in the chemical equation to any other substance in the chemical equation, because the balanced equation relates substances in terms of moles. So if I had the concentration, if I knew the concentration, the molarity of the solution containing substance B, all I would need is the volume to get me the number of moles. If I knew the volume, all I would need is the concentration to get the number of moles. And so all of these relate to each other through moles. I can start with a concentration and figure out a mass, or start with a mass and work my way through and figure out a concentration if I've got the volume. Let's go through one example of this. So how many grams of lead iodide would be produced from the following precipitation reaction, shown here, if you start with 20 milliliters of 0.122 molar lead nitrate? All right, so what have we been given? We've been given a balanced chemical equation, and we're asked about how many grams of lead iodide, how many grams of this solid are you going to produce if you start with 20 milliliters of this concentration of lead nitrate. Well, the balanced chemical equation is the only thing that allows us to relate two different substances to each other. So what we need to have a value in moles, because the balanced chemical equation only relates things in terms of moles. So I have a volume and I have a concentration. So I can find the number of moles of lead nitrate using the volume and the concentration. Molarity is moles per liter. So I'll simply convert my volume to liters and then use the molarity as a conversion factor to convert from volume to moles. So I'll do that first here. So convert my volume to liters, then use the molarity, moles per liter, to cancel out liters, and that comes out with 2.44 times 10 to the minus third moles of lead nitrate. Now I need to relate the number of moles of lead nitrate to the number of moles of lead iodide. I need to be able to relate, I need to go from lead nitrate to lead iodide, because it's only after I get to lead iodide that I will be able to figure out how many grams of lead iodide I have. So I can do this with a balanced chemical equation using the coefficients. In this case, it's just 1 to 1. 1 mole of lead iodide is equal to 1 mole of lead nitrate. I simply arrange it to cancel out the moles of lead nitrate. That gets me the same number of moles here of lead iodide. And now, once I have moles of lead iodide, I can go to mass of lead iodide in grams just simply using the molar mass. And I can look up the atomic weights of lead and nitrogen and oxygen to figure out the molar mass or the molecular weight of lead nitrate. In this case, or actually what I'm looking at here is not lead nitrate. That's what I started with. But what I want is lead iodide. So I can look up the atomic weights of lead and iodide or iodine and figure out the molar mass of lead iodide, and then use that to convert between moles of lead iodide to grams. So here, the molecular weight or molar mass of lead iodide is 461.01 grams per mole. I arrange it to cancel moles, multiply through to get me 1.12 grams of lead iodide. That is how we use solution concentration to relate to the balanced chemical equation and between mass of various substances.